Hello and welcome to this new video. This video will focus on how to calculate the volume of a frustum of a coin. So what we're basically doing is we're advancing um, with a continuation of what we looked at in the previous video. So in the previous video we looked at how to calculate the volume of a coin. Now that will help us be able to understand on how to calculate the volume of a frustum. The reason being is that a frustum is some certain of a shape that comes in existence only when a corn has been cut. Okay, so like I was saying, a frustum is basically a shape that comes in existence after a coin has been cut. So basically, when you have a full normal coin and then we cut it, what will remain with after removing the top part is what we are calling a frustum. So therefore, when we are asked to calculate the volume of a frustum, we need to first understand the amount of space the corn had before it was cut. This simply tells us that before we are able to do that or calculate the volume of a frustum, we need first of all to find out three things. Number one, we need to be able to understand the full height of the full corn before it was cut. Number two, we need to understand the amount of space the big corn had before it was cut. And number three, we need to understand the volume of the small corn which was cut out of the big corn. Okay, therefore, we can now understand the amount of space the frustum will consist after subtracting the volume or the amount of space of the big corn minus the amount of space of the small coin. What remains is the volume of the frustum. But before we do that, let's look at how a frustum is formed. You can see that the first diagram is a full coin which is being cut. So the yellow shaded region is showing that we are cutting the full coin. In the next diagram on the center, you'll see that now we've successfully cut the coin and we've split into two different figures. On the top, we can see that we have a small coin that has been formed after the big coin has been cut. And below, we can see that the shape remaining does not look like a cone anymore, but now instead, after separating the small cone on top and down part, what remains is what is known as the frustum. So the third diagram here on the far to the right is a frustum of a coin. Let's look at the features of a frustum. So a frustum will consist of the following. After cutting the full coin, what remains is on top we will have a circle, and the base of that particular frustum will also consist of a circle. Therefore, we'll have two circles, the top and the down part. We will also have the height, okay, which is representing h, is our perpendicular height. And of course, we will also have the slight height. All right. Therefore, we are able to calculate the volume of a frustum by getting the radius of the top part to the ratio of the radius on the down part, which would be equal to getting the height of the small cone which was on top to the ratio, the full height of a frustum, plus the full height of the small cone which was cut. So let's look at a sample or a question that I sampled from the past paper. This is ECZ past papers, and according to this question, it says that the figure below is a frustum of a coin. The base diameter and top diameter are 42 centimeters and 14 centimeters respectively. While the height is 20 centimeters, take pi as 3.142. The question says calculate volume. So you can see the frustum that we have here has a height of 20 centimeters, and the base or the base diameter is 42, meaning that the radius is 21. We can also look at the top diameter, which is 14 centimeters. That simply means that our radius is 7 centimeters. Let's now look at how we can solve this question.
Okay, so I've roughly drawn the frustum that we are given in the question so that we can do the solvings together. So what I've drawn here is the frustum which was given. Okay, so with the top diameter of 14 centimeters and the down diameter of 42 centimeters, with the frustum height from here to here as 20 centimeters. Remember, the first thing we have to do for us to calculate the volume of a frustum is first of all to calculate the full height of a coin. So what I've drawn here is an imaginary part of the coin that was cut out. Okay, so you can see this is the sample of the imaginary coin which was cut out for us to have a frustum in black here. So you can see I have drawn the small coin which came out after cutting this coin, full coin, and the part on top here made this small coin which has a radius of 7 centimeters, which makes sense with the diameter of 14 centimeters. So the radius has been found by dividing the diameter by 2. That simply means that we need to know the height of that small coin. So I'm calling the height as x. That simply means that for us to find the full height, we have to say the x plus the 20, which will give us full height. Why am I saying so? Because we're saying from here to here is 20 centimeters. Meaning, if we add the distance from here to here, or the height, plus the height from here to the top there, meaning we found the full height of this coin. How do we do that? We use a concept from similarities and congruent. It's a topic, a grade 10 topic that we did. So we're going to do a comparison. We're going to say the circle here from the small coin has a radius 7 centimeters. This, however, will be compared to the ratio of the radius of this big coin. So the radius of small coin to the ratio, the radius of the big coin. So meaning 42 divided by 2 will be 21. So we just do that. Is equal to the height of a small coin to the ratio the height of the big coin. So the height of the small coin to the height of the big coin. Therefore, this will now be expressed in ratio form as R over capital R is equal to X over X plus 20. Then let's do the replacements. The small radius is 7 centimeters. You can see here that it's 7 centimeters. Simply the radius of the top circle. So that is going to be 7 centimeters over the radius of the big circle here, which is 21. 21 is equal to X over X plus 20. At this point, all we have to do is cross multiply. So we're going to have 7x plus 20 is equal to 21 times x. So we'll have 7x plus 7 times 20 is 140 is equal to 21 times x is 21x. Then we can collect like terms. So we'll have 140 is equal to 21x minus 7x. Therefore, we'll have 140 is equal to 21x minus 7x, that is 14x. Make x a subject because that's what we're calculating for. We multiply both sides by the inverse reciprocal 14. That will leave us with x, and 140 divided by 14 is 10. So basically, what we're trying to say is that the height from this point to far point there is 10. Therefore, the full height of the big cone is going to be, the full height is equal to 10 plus 20. So the big cone full height is 30 centimeters. After finding the full height, we now need to calculate the volume of the big cone. Let's now calculate the volume of the big cone. We know that volume of cone is equal to, 1/3 by r squared h, which is height. Okay, so we can go into our calculations. 1/3 times, we were given pi, that's 3.142, times our radius for the big cone is 21 centimeters, times 21, which is r squared. That will be multiplied by the height of the full cone, which we found as 30.
Let's see how we can get this by punching on the calculator. Okay, so you can see we have 1/3 times 3.142 times 21 times 21 times 30. All we have to do is punch that on our calculator, and then we should get the volume. So we have 1 times 3.142, so that we have 3.142 times 21 times 21 for r squared times our height, which is 30. That should be divided by 3. And our volume is 13,856.22 centimeters cube.
So we found on our calculator that the volume is 13,856.22 centimeter cube. So that is the volume for the big cone. Now we have to calculate the volume of the small cone. Remember, our small cone had the radius of 7 centimeters, the height which we found as 10 centimeters. Therefore, we can now calculate the volume of this small cone. Volume of small cone is 1/3 by r squared h. Therefore, we'll say 1/3 times pi, which was given as 3.142, times the radius of a small cone is 7 centimeters. So we multiply 7 times 7 for r squared, times the height, which is 10. Let's try to punch that on the calculator and see what we get as volume. We have 1/3 times 3.142 as pi, times the r squared, which is our radius, 7 times 7, times our height of the small cone, which is 10 centimeters. We can punch that on the calculator and see what our volume will be. 3.142 times 7 times 7 times 10. What we have is 1,539.58, so we have to divide that by 3. So our volume for the small cone is 513.193. We can take note of that as 513.193 centimeter cube. Now that we've found both the volume of the big cone and the volume of the small cone after it was cut, we can subtract the volume of the big cone minus the volume of the small cone. What will remain is the volume of a frustum. Okay, so volume of a frustum will be equal to the volume of a full cone before it was cut. We have realized that it was 13,856.22 centimeters cube minus the volume of the small cone, which we found as 513.193. So let's just punch that on our calculator, and then we can see what the volume of a frustum is. We have 13,856.22 minus the volume of the small cone, 513.193. So our volume for the frustum is 13,343.03. Okay, so we can take note of that. We are saying it is 13,343.03 centimeter cube, and that is how we can get the volume of a frustum.